Hello again. We're still looking at oxidation and reduction half reactions, they're called. And you saw in the last example, if you followed that one, that I was adding electrons to one side or the other to make the reactions balance. We weren't technically required to do that in the first question, but now we are. So we have to figure out the total amount of charge at the beginning of each half reaction and the total amount afterwards, and then we add electrons to get those numbers to match. So in this first thing, X2 has no charge, or its oxidation number is 0, so total charge on the left, 0. On the right, each of these ions has a -1 charge, and there are 2 of them, so we have a total of -2 charge there. These are not the same. We add electrons to the higher side to drag it down, so this half reaction balances if we put 2 electrons on the left. That would mean our total charge is now -2. Before, -2 after, and that's considered balanced, so that's what we want. Not bad. We can knock off the rest of these without too much trouble, I think. +4, +2 are the charges. The higher side is this one, and if we add 2 electrons to it, now our charge on the left is 4, take away 2 is 2, and on the right side it's just 2. So we have successfully balanced the charges. Phosphorus has no charge. There's no number up here, so the total charge on our left is 0. What is it on the right? Don't say -3. It's -3 per phosphorus, but there are 4 of them, so the total is actually -12. So if we're going to balance this, the higher side is 0. That's way higher than -12. If we're going to make them equal, we must add 12 electrons to the higher side. Now the total is -12 on the left, -12 on the right. We're good. Okay, Z is not a real element, so we can call it whatever we want. -5 charge on the left, -2 on the right. This is our higher side, so to fix this, we must put 3 electrons there. Now we have -5, -5. Sulfur has a total charge of 0. Sulfide ions are -2 each, but we have 8 of them, so the total on the left is actually -16. If we were to balance this, we'd have to put 16 electrons on the right-hand side. Copper 1 to copper 2, the charges are +1 and +2, so a single electron would do it here. Now our total charge on the right is 2, take away 1 is 1. You can put 1E here, or you can just leave it as E, whatever you like. Aluminum, this is 0, this is +3, right side's higher, we put 3 electrons to drag it down. And last one, sulfur again. Total charge on the left is 0, because molecular sulfur has no charge. Multiplying by 3 doesn't change that. And on the right, we have -2 charge per sulfide ion, and there are 24 of them. So 24 times 2 is -48 charge. To balance this, we would need, thinking 48, I don't know where that came from. We need 48 electrons on the left side to balance the charge in this.